Okay guys, welcome to 7.3. This is shell method. So before we've learned disk and washer, now we're on to shell. Shell is a totally different approach. Our goal is the same, and it would be like to find the region between F and the line Y equals 0, and then rotate this around to find the volume. So the initial idea is the same and the goal is the same. It's just our approach will be different. So in the past, what we did is this would be washer. You would go axis of rotation to furthest away curve, axis of rotation to closest curve. And because that's a line and that's a curve, we would then have to do it again up here because the right side function changes. What shell is going to allow us to do is only look at what we want. And a little way to remember that, remember we said perpendicular. You can also say that this is parallel. Do you see the two L's, parashell, we'll call it. So if this is the axis of rotation, our rectangles are now parallel to the axis of rotation. So parallel, where in the past they are perpendicular. Think about this rectangle, and as it swings around, it's going to make a cylinder. Like I want you to picture the soup can on the soup label on a soup can. So it doesn't have the top and bottom. So do you see how there's no top and bottom over here? So here's our region F. But I wanted you to get a feel for what the 3D shape would be like if we rotated it around. Also, if this is the rectangle I'm looking at and it makes this cylinder as it swings around, there's going to be another rectangle right next to it that's going to swing around. So you're going to have a whole bunch of cylindrical shells is what they're called. You'll see it says right here. Kind of like if you can imagine the baby toy where you have like the nested blocks or the nested I don't know what they're called. We'll call them shells here. But then when you turn them over, you can make a tower. So we're going to find the cylinder, the surface area of the lateral surface area of a cylinder, an infinite number of times because there's an infinite number of rectangles creating an infinite number of cylinders. If you think about the surface area of a cylinder, it's 2 pi r squared because those are the top and the bottoms of the circle, plus 2 pi r times the height. But we don't have this because we don't have a top and a bottom. So we're just going to do this. Yesterday, when we integrated an infinite number of circles, we integrated pi r squared. Now we're going to integrate 2 pi r h because now we have an infinite number of shells, cylindrical shells, if that helps. Okay, so I have this box in all of the notes from disk, washer, and now shell. So let's say we have this curve bounded by this axis, and let's say we're looking at this shaded region, and let's go from C to D. I want to rotate this around the x-axis. So my rectangles have to be parallel to this axis, so they go this way. I forgot to say that. Notice here, parashell, just to help you remember. Okay, so now here, as you rotate this around, can you imagine the cylinder? So you have this rectangle that's swinging around and around and around, making the cylinder. Above it, there's another rectangle doing the same. So we have an infinite number of these. Do you see the 2 pi RH? These are stacked up this way. That's why Y is involved. Goes from C to D. Over here, we're going to rotate this around the Y-axis. And if our region goes here from A to B, you can see on this, if this is your axis of rotation, again, we have to be parallel. Can you imagine this swinging around and making a cylinder? And then right to the right, we're going to have another cylinder, etc., etc. I do want to point out one thing now, though, is on the cylinder, let's go back to this one. Do you guys see that this is the radius and this is the height? I need you to be able to identify it. That's why I want you to picture this drawing around. I still draw these cylinders in. I think it's an awesome tool. This is R and this is H. Okay, the thing I like about shell is remember, and don't write this on your sheet because it might be confusing, but remember when we did this with washer, or let's do this region. If we were rotating this around this axis, we would go axis of rotation, curve furthest away, axis of rotation, closest curve. Our rectangle was never what we wanted. We had to find everything and take out what we don't want. What I like about shell is we're just highlighting what we want. Okay, and I will make it known in class that I love the shell method. Okay, the ones I'm going over with you today, either method will work. Sometimes one method's better than the other. So sometimes disk is better, sometimes shell is better. It's going to depend on if we can get x and y alone. And I'll again explain that as we go on. So this problem we looked at yesterday. We had this piece, which was disk, and we had this piece, which was washer. So we had to do two separate things and then add them up. And it was quite a bit of work. If you look at the same problem now, so let's sketch this quickly. We have x equals 2. The curve is the parabola shifted up 1 unit. It hit at 5. So here's our parabola, bounded by this, bounded by x equals 0 and y equals 0. We're rotating this around the y-axis. Now we're parallel to the axis of rotation. As this swings around, it makes a cylinder. This is the r and this is the h. So v is going to be 2 pi. Look at these rectangles. Imagine you're back in 7-1. They keep getting stacked up on the x-axis, and x goes from 0 to 2. Now, we said that we're integrating 2 pi rh, so I need an r and h. This is not a division symbol. I'm just showing you that we need a spot for r and a spot for h. I need x's involved. This is my radius right here. Now, notice I gave one rectangle, but there's an infinite number. So if this goes over here and we have another rectangle, the radius keeps growing. So the radius starts here at 0, and imagine dragging this pink rectangle out to here, it gets as wide as 2. This is a horizontal length. To find a horizontal length, you do right minus left. The right is changing because this rectangle keeps changing. So the right is just x, but the left you always measure from this value because it's the axis of rotation, which is 0. So it's x minus 0. The height is this, top minus bottom. Top is the parabola, which is x squared plus 1. The bottom is y equals 0 dx. Another thing I like to do to check with my radius is we agreed that this pink goes from here all the way to here. So when it's here, the radius is 0. Well, that's when x is 0. So sub a 0 in, and what do you get? It's 0. Like, it's making sense. And this will get more complicated, so I want to make sure we get this down now. X is 2. If this pink comes over here, then our radius is 2. When I plug a 2 in for x, that's 2. So then you get 2 pi from 0 to 2, and you're going to get x cubed plus x. If we integrate this, we're going to get 2 pi x to the 4th over 4 plus x squared over 2 from 0 to 2. Continuing our work over here, if you sub a 2 in, you're going to get 2 to the 4th, which is 16 divided by 4 is 4, plus 2, because 2 squared is 4, 4 over 2. And then you're going to get 12 pi. And this is exactly what we got over here, but a lot quicker. So in this, not all cases is shell better, but in this case for sure it was. Okay, so all we have to get through today is the rest of these 4. I'm going to go through and just do the shell method. Notice that I asked the same question, but using different methods. I want you to see a side-by-side comparison. So let's look at this graph. We have x equals 4, and then we have the curve y equals x squared. This hits at 416. We're bounded by y equals 0 and x equals 4. Here's our region. We're rotating this around the y-axis using shell. Here's the y-axis. Shell is parallel. There's our parallel. Remember this rectangle, as it swings around, it's making a cylinder. This is the radius, and that's the height. Shell is 2 pi. We go from 0, look at these, get stacked up, use your 7-1 knowledge, from 0 to 4. Those are x values. I need x in here, I need an r, and I need an h. The radius keeps changing. This value is going to keep moving. It's changing. The right side is x, the left side is 0. Remember, the left side is the axis of rotation. So this pink, imagine this moving back and forth. Right now, the radius is any given x minus 0. The height is the top, which is the curve, minus the bottom, which is 0. If we expand this, all we get is x cubed, so this guy's not bad. You get 2 pi x to the 4th over 4 from 0 to 4. Now, a shortcut here is if you have 4 to the 4th, but you're dividing by 4, that's really 4 cubed. So we have 64, which is 128 pi. Okay, I'm going to go down to C. I'm not going to do a different method. I want to stick with shell because this is new to us. So let's look at this now. Okay, looking at this problem, we have the same graph, so we know it's bounded by x equals 4. We have this parabola. Here's 416. Here's the shading. We're revolving now around the x-axis. Remember, parashell is parallel to the axis of rotation. There's our rectangle. So imagine this swinging around, and we're here. So v equals 2 pi. Now look at this, goes all the way from 0. These are y values. See them touching the y-axis to 16. I need r and an h. This is the radius right here. Now this is on its side, so height doesn't have to be vertical. This is the radius and this is the height. The radius, now look at this rectangle, keeps changing. It goes up and it goes down. So it's varying on y, but it always goes to the axis of rotation, so y minus 0. And then the height is right minus left, because this is the height. I need y involved. Oh, but remember we had this. So if I want y involved, I have to solve for x. X is root y. So this is going to be the right side is x equals 4 minus root y. This r and h is not necessary. I'm just putting it in the notes to show you what they are. So now when you integrate, let's expand and get 4y minus y to the 3/2. Go ahead and integrate that. We're going to get 4y squared over 2, which is 2y squared, minus y to the 5/2 times 2/5 from 0 to 16. So we substitute a 16 in. You're going to get 256, double this 512. If you sub a 16 in, the 2 means the square root, which is 4. 4 to the 5th is 1024. So we have 2/5 times 1024. And if you go ahead and get a common denominator, I'll let you do this on your own. You get 1024 pi over 5. So today is just day 1 of shell. We were only rotating around the different axes, just like disc and washer as it picked up, we did different axes. We can do a side-by-side right now looking at the same region. We should end up with the same answer, but now we're going to use disc or washer. So let's see which one we need. We have this, we have x equals 4, and we have the region here. This is supposed to hit at the origin. We're revolving around the y-axis. Now, disc and washer is perpendicular to the axis of rotation. So look at the difference. This was shell, this was parallel, now it's perpendicular. Can you see if you start drawing your rectangles in, we have this void here. So that means that it's going to be washer. It means we have to take out some extra. So you go to the line of rotation to the curve furthest away, then you go line of rotation to the closest curve. Okay, so V equals, move this up a little in case we need the space. Okay, so now here we are integrating circles because as this swings around, it makes a circle. So we need pi r squared. So pi, remember this intersection was 416, we know that from earlier. These values go this way, so they go from 0 to 16, and those are y values. That means I want x equals. So I'm going to look at big R, which is the pink rectangle. You go to the right, which is 4. If I want y in here, it has to be x equals. So it's x equals 4 minus x equals 0 squared minus, now little r. I want y involved, so I want x equals. So x equals root y minus x equals 0 squared all dy. So from 0 to 16, this is 16 minus y, 4 squared. The square cancels the root. So now I have 16y minus y squared over 2 from 0 to 16. 16 squared is 256. 16 squared is 256, cut in half is 128. And then we get 128 pi, and I'm really glad we got that because that's what we were expecting. Okay, so there's a side by side, same problem, same answer, different methods. And like I said, we'll run into some cases where we can't use both methods, but the reason we're allowed to right now is because I can isolate an x here and I can isolate a y. It already is isolated. When we find something that can't be, that's when we'll have an issue. Okay, let's wrap it up. So this one, x equals 4. Again, with the parabola, this is 416, revolving around the x-axis. Disk and washer are perpendicular. Look at the shaded region. Do you see how it goes right up to the line of rotation? That means it has to be disk. Again, if you look at this shaded region, it did not go right up to the line of rotation. We had a void. Okay, so V equals pi. Let's draw these in. Perpendicular goes this way. Look, it's always parabola to line. So we're good here. There's no void. This is disk. These get stacked up on the x-axis. We go from 0 to 4. If it's x, I want x in here. That means it's y equals. So y equals the top curve is x squared. Y equals the bottom curve is 0. Pi r squared dx. Pi from 0 to 4. X squared squared is x to the 4th. Which gives us pi x to the 5th over 5 from 0 to 4. 4 to the 5th, did we do that earlier somewhere? I think so. It should be 1024. Yes, 4 to the 5th is 1024 over 5. If we sub 0 in, it's gone. So we get 1024 over 5 pi. And again, we know we're good because look at same answer. Okay, so that gets us through day 1. Make sure you have this down before you come to class tomorrow so we can look at day 2 and we're no longer just looking at x-axis. We start looking at different lines like x equals 4, y equals 2. Okay, see you guys later.